Assalamualaikum and good morning. In this video, we will present our project on a smart walking stick for elderly people under theme 2, which is accessibility and mobility of people with disabilities. First of all, let me introduce my team members. This is our leader, Muhammad Firdaus bin Azman. This is Nuratul Aisyah binti Muhammad Azhar. This is Muhammad Shakur bin Muhammad Sabri. And this is me, Roshada binti Ahmad Farid. We are from Group 17, which is supervised by our mentor, Dr. Anas bin Abdul Rahman. Part 1. Overview. First, what is meant with a smart walking stick? A smart walking stick is an aid tool or a device that can improve accessibility and mobility linked with the IR 4.0 and Sustainable Development Goal to solve muscle weakness and loss of body balance problems. Second, who are the main target user for the smart walking stick? So, the main target user of the smart walking stick are the elderly people. So, who is elderly people? Conventionally, elderly people has been defined as a chronological age of 65 years old or older. Next, how the smart walking stick operate or working. First, support the user weight while sitting, standing up, and walking. Second, monitor and track user movement. Third, trigger an alarm if an emergency happens. Second part is problem statement. In this section, I only highlight the main problem that often happen to the elderly people. There are a few biggest problems or issues that usually happen to elderly people. First, difficult to work and move. Second, difficult to stand up and stand down from seat. Third, senile and easy to lose direction. Fourth, difficult to ask for help when falling.
Hello everyone, I will explain about the survey analysis part. This survey has been conducted with 100 respondents from the working cane user and the relative of the user. Problem faces by user. For the survey analysis, majority of the respondents chose strongly agrees on the problems. There are not a lot of facilities for senior citizens in their place by 32.67%, and the second, the users have to hold on to something when walking without the working cane by 37.62%. And next, majority of the respondent chose agrees on the problems. The user have to sit after walking for a while by 44.55%. Their leg feels weak when walking by 39.6%. And lastly, the user wobbled while walking by 38.61%. The solution provided, including the safety and practicality element, to be implemented into our project and prototype. For the possible solution provided, most of the respondent agrees with all the solutions provided, and the highest percentage, which is the walking cane, has a stable element under the cane by 68.32%, followed with the second ranking with 54.46%, which is the walking cane has location tracker, which is GPS, global positioning system, to track their location.
Next is methodology. In methodology, we have 8 steps before we are able to produce the prototype. First step, we define the project. We identify the problem and do some comparison between the existing product in the market as our benchmarking. After that, we get some information regarding our project by doing some survey and distribute questionnaire to get some feedback about our project. Not just that, we also refer some article and journal to get more knowledge about our working stick. Next, in concept generation, we get some feedback from the survey and questionnaire with brainstorming the idea, the key performance targets, and about special features that we can include in our project. Then we come up with the idea, which is smart walking stick for elderly people. Next, we evaluate the concept by deciding the design based on the selection criteria that we have. For the design, we come up with 4 designs and choose best of the best, which is in accordance with the wishes of the user. The relationship between the define and evaluation concept is conceptual design. After that, we have arranged the physical element that required to build our smart walking stick for elderly people. In configuration design, we select the best material and modeling for the product in order to fulfill the user's requirement. Embodied by design is this relationship between product architecture and configuration design. For the sketching and drawing, we use CAD software such as SolidWorks and CATIA. As for mechanical design, we use ANSYS for analyzing strength, toughness, temperature distribution, and other attributes. Lastly, in detail designs, we produce the prototype and tested it. We also made some improvement and further exploration to produce best product for elderly people. For the next slide is selected design concept. This is our smart walking stick for elderly people. The features include in our product a massage plate that can support maximum weight until 226 kg, the rubber hurricanes that works as anti-slip and to increase the friction when user using it, T-bar handle, which the design is comfortable and easy to grip, and our product also include with knee bar that can help elderly people whenever they want to get up or sit down without need some other support. The knee bar also can be foldable to save more space. For LED light, it can be adjustable for high beam and low beam. For the master lock, the user can adjust the height of the smart walking stick at 5 adjustable height. In the circuitry box, there is a storage for place of the circuit that control the system of the smart walking stick. Next is the USB charging port. The USB charging port is the place where the power bank located. The user can recharge the battery when at the lower power. Last but not least, our smart walking stick also included with 3-leg base to support the user when walking and sitting.
Next, key subsystem. This is physical decomposition of smart walking stick for elderly people. From this physical decomposition, there are 4 main subsystems that will define our smart walking stick system, which are power supply, Arduino or microcontroller, electronic, and substructure. First, from power supply subsystem, there are rechargeable battery and universal series bus USB connection. From this project, we use power bank as rechargeable battery to supply power into smart walking stick system. Then USB is provided to carry power as well as a signal to recharge the battery. Next, for Arduino or microcontroller subsystem consists a accelerometer sensor and global positioning system GPS module. A accelerometer sensor is a type of low power radio wave technology sensor used for user detection when falling and to monitor the movement of the user. Then, GPS is used for tracking the user location. For electronic subsystem, there are LED light and alarm. The LED light can be adjusted and can help user work in dark area, especially at night or early morning. While in alarm system, we use a GE buzzer. This alarm works by emitting sound wave at a frequency too high for human to hear, which is 18 decibel. Lastly, substructure subsystem. This subsystem consists of SIG and MIBA. The massage seat plate is designed to provide extra comfort to the user and prevent user from sleeping when sitting. Why the font Niba design has an artistic feature that provide balance while users stand and sit.
Assalamualaikum warahmatullahi wabarakatuh. Okay, I will continue with analysis of prototype. We choose Software Analysis Workbench as our engineering simulation of prototype. Analysis Workbench platform can integrate data across engineering simulation to create more accurate model and more efficiently. Okay, next, Analysis Workbench can determine the effect of load on physical structures and their component. Okay, why we choose Analysis Workbench? Because first, easily to manage data across all ANSYS product. Okay, second, integrate multiple analysis within a single interface. Third, save time with automated data transfer. And lastly, create higher fidelity model. In this project, structure analysis is performed into three different of component, which is first, handle, second, seat, and the third is body part. Okay. As a result, this analysis is performed to test out the total deformation and elastic strain of the components. Okay, next we continue with the analysis of body part. Okay, first of all, we input geometry from the CATIA and we select aluminum alloy as our material. Then we mesh for the whole body part and we insert fixed support and force at the body part. Okay, fixed support we apply at the bottom of body part. Okay, force number one, we apply about 1471 Newton, which is 150 kilogram at the root of body part. Okay, force number two, we apply at the upper of body part, which is 196 Newton, and we assume at this part about 20 kilogram of force. Okay, the third force, we apply at the left of footrest, which is 196 Newton, and we also assume at the left and right is 20 kilogram of force, and the force number four at the left of footrest, which is 196 Newton. And to solve the result, we insert the total deformation and equivalent elastic strain. Okay, the total deformation, we have maximum and minimum, which is 0 minimum for minimum, and we have 0.001718 for maximum. In result for equivalent elastic strain, we have 1.0737 times with 10 to the power of negative 9 for minimum, and maximum we have 0.001435 for the maximum of total of equivalent elastic strain. Okay, we can see the simulation. Okay, I set to the 2 second. Okay, for the total deformation, we can see the graph which is 0 to 1.1718 times 10 to the power negative 3. Okay, the 9, then equivalent of elastic strain, we can see the simulation. Okay, we have, okay, that's all for the body part. I will continue with the second part of analysis, which is seat. Okay, first of all, same with the body part, we input geometry from the CATIA file and we select the material. Okay, then we mesh for the whole body of seat. Okay, for the seat, we have compared the element size for matching, which is firstly we set as default, and second we set as 8 meter from the actual size of seat. Okay, then we insert fixed support and force for the static structure. The fixed support we apply at the hole and this part, because this part will attach with the body part. Then we apply force about 1417 Newton at the upper, and second force at the lower, which is same also 1417 Newton. Then to solve the result of the analysis, we insert total deformation and equivalent elastic strain. Okay, for the total deformation, we have 0 minimum, and we have 4.1512 times with 10 to the power of negative 0.006 for the total deformation, and the result for equivalent elastic strain, we have minimum 4.1294 times with 10 to the power of negative 0.008 and 1.663 times 10 to the power of negative 0.005 for the minimum of equivalent elastic strain. Okay, we can see the simulation for equivalent elastic strain, and we can see the total deformation of simulation. Okay, we have maximum result at here and minimum result at here. Okay, that's all for the seat. Okay, lastly, the third of analysis, which is handle. Okay, first of all, we input geometry from the Katia file and we select the material. Okay, then we mesh for the whole of handle and then we apply fixed support and force for the static structure. The fixed support we apply here because this part will attach with the body part, and force we assume at the upper of handle that it has 20 kilogram of force, which is 196 Newton. And then to solve the result, we apply total deformation and equivalent elastic strain. Okay, the total deformation, we have 0 minimum and the maximum is 2.1706 times with 10 to the power of negative 0.005. And for the equivalent elastic strain, we have 1.7111 times 10 to the power of negative 0.008 for the minimum, and the maximum we have 7.7333 times with 10 to the power of negative 0.005. And we can see the simulation for the total deformation. We have minimum at here and maximum at the left and right of handle, and we can see the simulation of equivalent elastic strain. Okay, to conclude, as the result, we achieve the result of simulation is achieved for the design of this project. Okay, that's all from the analysis.
Hello everyone. So I will explain about each component we use for our prototype first. So let's start with the Node MCU. So this is the Node MCU ESP8266. The function is to connect all the components and transfer all the data through Wi-Fi connection. The second component is the passive buzzer. The passive buzzer is to make alarm sound to attract other in emergency case. And the third one is the MPU 6050 accelerometer gyroscope module. The function is to detect vibration or the sudden impact of the user and send the data to the Node MCU. And the fourth component is the GPS Neo 6M module. This GPS module was functioned to detect the location of the user and send the coordinate to the Node MCU. And the other components is like transistor, resistor 10 kilo ohm, and also the breadboard. And we use single core hardwire to complete the circuit. Hello everyone. So I will explain about the fabrication process of our prototype. For the hardware part, firstly, we disassemble all parts of knee bar before grinding. And second, making a hole using drilling machine by 7mm size to install the knee bar. The third, to decrease the thickness of the footrest by 5mm using grinding machine. And four, all the part was assembled with the other components, and we go to the electronics part. All electronic parts were attached on the breadboard flowed with that already been created using the circuito.io software. Then we have to check the current flow of the circuit. Next, soldering the main header to the sensor module. And then we go to the assembly part. For the assembly of all components, this process considers all the parts like circuit boards, power bank casing slot, knee bar, and electronic components. So, this is the final view of our prototype and already been tested by our team.
And lastly, I will continue with the last part of this section, which is conclusion. Okay, first of all, prototype procedures able to meet market requirements such as the product ability to detect location, alert the surrounding, user-friendly, and have a system with high durability that is safe and easily portable. Second, objective in this project. Firstly, apply the knowledge in study to the community. Second, we have achieved the Sustainable Development Goal number 9, which is to develop quality, reliable, sustainable, and resilient infrastructure to support human well-being, focusing on affordable and equitable. Third objective is element IR 4.0, especially for the fall detection system. Okay, the third conclude is more research and experiment have to be done to improve better design and accuracy system as the technology grows. And lastly, hope other students and community to make more research and experiment as the technology grows for better future. I think that's all from us. Thank you for lending your ears. Assalamualaikum warahmatullahi wabarakatuh.